Good morning. So I'm Stan Larocque. I'm the CEO and founder of Lynx Mixed Reality. We are a French company based in Paris. We are a small and mighty team. And 2 years ago, I was on this stage, and I told you that next time I would be back with a new product. So here we are. I'm very pleased to tell you more in great details about our next product that will come online this year, the Lynx-R2. We're going to talk, of course, about optics, which is an important feature of our headset and of the last 2 years of our work. And we're going to skim over what makes this platform very special, so the sensors, electronics, the design itself, of course, and part of the software. So here it is. So this is the Lynx-R2. It's a major upgrade to the Lynx-R1 that many of you have seen these last few years. I have one here, actually, with me. If you want to try it, I'm going to start making demonstration at 3 p.m. I'm going to show you videos of the headset through the lens and interesting details, but I really encourage you to try the device. It's not the same as watching a video of it running. So it's a completely standalone device running the latest Qualcomm X-R2 Gen 2, state-of-the-art optics, and we'll deep dive into that very soon. A lot of sensors. It's a future-proof platform, meaning that the product I'm presenting today is running the X-R2 Gen 2, and the same platform will be able to run X-R2 Gen 3 in the near future. The optical system of this headset has been a major pain for our team and for all our partners. Some of them are in this room this morning. Thank you very much. I'm going to give you the exact numbers of the eye box, the eye relief, everything you want. But first, we're going to go through the design principles that went through our head when we started this design 2 years ago now. So we kept the good ideas of the Lynx-R1, and we upgraded what we thought was wrong at the time, and I hope you'll enjoy it. So we keep the weight distribution with the battery at the back. We, of course, have the signature flip-up of our headset, which is really appreciated by developers and by the community. You don't need to remove the headset to just look at your phone, which is important nowadays. Every curve is following a function and optimal peripheral vision. I will go back to those two lines very briefly. But like the Lynx-R1, every mechanical curve was a function of either the sensors or the optics. Every headset, every pair of glasses on the market is a compromise today. So I think you will understand the compromise we made with this product. We still have those detachable interfaces. You can wash them. They're attached with magnets. We did some additional work on the material. We had more resources to work with the material of this headset. So 3 years ago, we were a 10-people startup. Now we are a 25-people startup. We have plenty more people to work on things that didn't really caught our attention. And I have a very young hardware team. And that team is very conscious about the usage of our product and the life cycle. So I'm not sure it's very relevant in the US anymore, but we use bio-based plastic. We have a better ease of access to service the battery. And we try to use screws when we can avoid glue. All those details are important because the people buying our devices are very big companies, and they cannot just buy e-waste anymore, and we have to be very conscious about how we design those devices. OK, let's get technical now. So the optical stack of the headset is a pancake system. To be more precise, it's a spherical aspheric pancake lens with 2 pieces, and you have a side view of the design here on the screen with the specs. What is interesting in that design and why we adopted it is that, as I told you, it's also part of our future-proof strategy. It's only 2 pieces, but the difficulty of the design is that it's spherical. So you might see that there are things missing in the side view here between the two lenses. You should see a quarter wave plate and a reflective polarizer for a pancake system to work. And those films are hard to laminate on a sphere. So Apple Vision Pro, what they did was smart. They designed around a cylinder, which is easy to laminate films on. Our design is spherical, and it was really, really difficult to productize that. We needed to develop new process with our manufacturing partners in Asia. We had help for this optical design. I advise you to reach out to this company in Israel called Hypervision. This is the first product, consumer product, that will reach the market with this Hypervision solution. The spherical aspect of this pancake lens makes it that there is nothing better to stretch the field of view than a sphere. So as I told you, Apple Vision Pro, on simpler systems like, for example, the Quest or the Pico headsets, you always have a planar surface to laminate your films. This is at the cost of the performance of the design. In Apple Vision Pro, they did a cylinder, and here we are at the spherical level. So for us, it was very interesting to reach those new values for the field of view, and the aspheric nature of the design makes it so that we still have a good PPD at the center of the image. So you can see that the display we're using today is a fast LCD 2.24-inch panel. It's 2.3K, and it's cheap. The full system is extremely cheap, and this is also a huge consideration in the design. We're not building a very premium headset. We're building a headset that we want people to afford and to buy and to use. So this LCD is $30. Compare that to a 4K micro OLED that is $300. That is a huge impact on your bum. Funny story, this LCD was paid by Meta, actually. This was supposed to be the display used in the Meta headset that was canceled last year. So as a startup, we were able to leverage the supply chain and the efforts of very big tech companies. Thank you for that. Yeah. The eye relief value is not complete here in the table. You can change the eye relief of the headset. There is a mechanism to push it inward and outwards. So most people can wear their glasses with this headset. You can go from 10.7 millimeters up to 26 millimeters of eye relief, which is important for some use cases. The horizontal field of view is 126 degrees, and the diagonal field of view is more than 130 degrees. It's the widest field of view in any standalone headset. And as I said, it's also great on quality at the center of the image because we maintain more than 20 ppd up to 30 degrees of rotation. So here is the kind of video you never see from other headset makers. It's a through-the-lens shot that we filmed 2 days ago with that device on the table. So you can see this 2.24-inch 2.3K panel doesn't yield screen door effect anymore. This was filmed with a super wide field of view GoPro. We had to actually tilt the GoPro outwards to get the peripheral vision in the field. What is great, what I really like about this, I'm going to use the pointer for that. This red LED and the white you're seeing here are reflection from the GoPro. Otherwise, we have pretty good performance, pretty good MTF, what we call edge-to-edge clarity for pancake lenses. And you can see what is super interesting between the Lynx-R1 and the Lynx-R2 is the reduction of obscuration of the headset when you wear it. This black line here is much slimmer than what we had in the Lynx-R1. Our goal was to make a headset that you don't see anymore when you wear it. We're almost there. With close collaboration between the optomechanical team and the optical design, we're able to design a headset that only obstructs 6% of the total field of view of the user. It's pretty amazing. So you have your direct peripheral field of view here with the peripheral vision that is more than 126 degrees, and you have the central field of view of the user that remains here. And that black line here is slimmer than most glasses and slimmer than probably all smart glasses that we see today. So this is a pretty compelling value proposition for a pass-through headset. So I invite you to try it. It's also a great perception platform. We have many, many sensors to do many things. All the bells and whistles you expect in a modern headset: 6DoF, head tracking, hand tracking, controller tracking, ring tracking. You're going to see a lot of rings next year. 3D room scanning, thanks to an array of sensors that is best positioned for facing the users and having two cameras seeing almost every point in the hemisphere facing the user. You can see on this diagram, this is a polar diagram of the cameras in front of the headset. The circle you see is 180 degrees. So it's facing the user, and you can see what you want is to have the minimum of blue. Blue is 0 camera. Orange is 1, and green is at least 2 cameras seeing a point. And you can see that in front of the user, with our headset, we have almost a stereo perception for 6DoF and hand tracking, and that is putting better performance on the whole tracking algorithm. Everything is synced. The IMU and the 2 IMUs also, and the 6 cameras are geometrically and temporally aligned at calibration during the fabrication of the headset. The developers can access those values. They can tap into the sensors. Here are the full specs. The slides will be available online too. So you can see it's not just a 10–20% improvement. For the last 2 years, we tried to improve with double digits, sometimes more, across the board for what matters in those headsets. What's interesting is the upgrade in GPU and DSP for running AI, real-time AI use cases, tapping into the pass-through cameras. So the pass-through cameras are 3K by 3K, but you can access a quarter resolution image directly with a hardware buffer on the system. So you can do real-time AI on the device with that, and the device is completely agnostic. About the software, of course, it supports OpenXR. It supports all the engines in the industry: Unity, Unreal, StereoKit. It's based on Android, but the open source part of Android, which is AOSP. So we leverage the full Android ecosystem. You can run 2D apps and 3D apps in the system. We also support WebXR, and the system is open, meaning that you can access a root firmware, and the bootloader is open for anyone trying to bring up Linux, for example, on it. The sensor access is paramount to us. Our users in defense, medical, or industry, they want to access those sensors. They want to feel that they own this device, which hasn't been the case lately for most of the devices on the market. And Lynx provides just that. You can, as a developer, you can tap into the raw data of the sensors. We're open sourcing most of our work. The mechanical design will be shared. And for the first time, we didn't do that with the Lynx-R1. For the Lynx-R2, all the schematics for the I/O features will be available on our developer websites. So if you want to plug your own sensors, if you want to change or swap a camera or a display, the Lynx would be a great platform to do that. Batteries, main boards, and camera modules can be bought separately from us directly as repair parts. If there are people in this room who want to build a headset now and use our optical engine, you can reach out to me. We are white labeling the full headset, but also the optomechanical combo of lens and display. This work has been extremely difficult, running with low resources 2 years ago, I was joking that a year of budget for us is 4 hours at Meta. Maybe this is changing now, but not a lot. And I would like to see that changing even more in the coming years. So that was a quick presentation of the Lynx-R2. It's coming this summer, but you can try it today. And we are going to do a trade show over the next few weeks. I really advise you to contact us directly and get in touch. I will finish my presentation with a quick word. We are clearly understaffed and underpowered for the ambition we have. So if you're an engineer and want to work for a business model that doesn't destroy the fabric of society and want to have any direct impact on the product, feel free to reach out to me. If you're an investor, I also encourage you to ask you to come forward and reach out to us because we're bringing real value. We cannot address the demand we have for the Lynx headsets. Many of you know that. So thank you very much.
Yeah, one thing that I really like is that you're building this system as an open system. We have heard a lot about the AVP, the Meta Quest, and also the Android XR. This, I think, is one of the systems that will allow people to develop based on a platform, on an open platform.
Yep.
So I have one question. Before going to, don't be shy, reach the mic. One question, how are you managing to develop this product with a limited budget, a limited team, and still having a good work balance? Is the most beautiful city on earth, right?
Okay, I think the expectation for what a good budget is has been skewed by the $100 billion that was spent over the last few years by very big tech companies. My point is that we've been doing that for 7 years now. I've been working on this system for 7 years. We provide better job security than most big tech companies today. You certainly don't need billions of dollars to build these systems. You need millions, and to put them on the market, tens of millions. We are doing integration. We're solving engineering problems. We're not solving science problems. I think people at Meta, for example, some of them are solving science problems. So it's an order of magnitude more expensive. So I don't have a right answer for that, but I think the expectation should be lower for what should be addressed for those devices.
Okay, we have a question.
On
the right side.
Thank you. Great talk. Quick question. You called it camera pass-through, but I assume that you're actually reconstructing the real world. So what is the latency in the real world view?
Oh, that's a great compliment you just made. Thank you. The image you actually saw was directly through the camera of the headset. The latency we have is between 12 and 20 milliseconds depending on the load of the system. We have graphics of that compared with the competition, but no one is looking at them. So I made a demonstration of skiing with the headsets that proved the point. The latency is super low. It's important for our customers, especially business customers. What is blocking the latency right now for us to get it lower is not the camera anymore. It's not the ISP. It's actually the display. We are using an LCD. If you use an OLED, you can almost achieve zero latency because you control every pixel on the display. With an LCD, you need to wait for the full image to light the backlight. So it's a trade-off, but we are at a level where we don't have any more customers. I never had a customer complaining about the latency, which I think is a great metric.
Thank you.
Any other question? Okay, well, I think we can thank again Stan for an amazing talk. And go and try the device out.